In this video, I will walk you through free response question number 4 from the 2003 AP Calculus exam. Let f be a function defined on the closed interval from -3 to 4 with f of 0 equal to 3. The graph of f prime, the derivative of f, consists of one line segment and a semicircle as shown above. Part A. On what intervals, if any, is f increasing? Justify your answer. A long time ago we learned the graphical relationship between f, f prime, and f double prime. Specifically, if f is increasing, then f prime will be positive. If f is decreasing, f prime will be negative. We can tell that f prime is positive in this interval because it is above the x-axis. Therefore, the original function f will be increasing from -3 to -2. We would say f is increasing on the interval from -3 to -2 because f prime is positive on the interval from -3 to -2. Part B. Find the x-coordinate of each point of inflection of the graph of f on the open interval from -3 to 4. Justify your answer. We know that a point of inflection occurs when f double prime changes signs. However, we have the graph of f prime, not f double prime, so we need to use the graphical relationships between f prime and f double prime to understand that if f double prime changes signs, that means that f prime will change directions, either from increasing to decreasing or from decreasing to increasing. Notice that f prime changes from decreasing to increasing at x equals 0. So this will be the location of a point of inflection. We say f has a point of inflection at x equals 0 because f prime changes from decreasing to increasing at x equals 0. Notice that f prime changes from increasing to decreasing at x equals 2. So we say f has a point of inflection at x equals 2 because f prime changes from increasing to decreasing at x equals 2. Part C. Find an equation for the line tangent to the graph of f at the point 0, 3. Whenever they ask me to find the equation of the tangent line, I like to use point-slope form, which reminds me that all I need is a point and the slope. And they gave us a point, so all I need is the slope. And we know in calculus that when you need to find a slope, you use the derivative. So we just need to find f prime at 0, the x-coordinate of our point. Since we are given the graph of f prime, we can easily see that f prime at 0 is -2. Now that we have a point and the slope, we can write the equation of the tangent line. We say y minus y, which is 3, is equal to the slope times x minus x, which is 0. So you could write the equation this way if you wanted to, but of course that 0 isn't really doing much, so we have y minus 3 is equal to -2x, and if you wanted to add 3 to both sides, you get y equals -2x plus 3. Good old y equals mx plus b. So that's another form of the equation of the tangent line. Part D. Find f of -3 and f of 4. Show the work that leads to your answers. Here is the first key concept that you need to know in order to solve this problem. The integral of f prime from a to b is the change in f from a to b. Let's consider the change in f from -3 to 0. So I have a starting value and an ending value. So in this case, the starting value of f is f at -3. If we then add the change in f from -3 to 0, We should then have the end value f at 0. But the change in f from -3 to 0 is the integral of f prime from -3 to 0. So now we have this equation. Since f of -3 is one of the things that we are trying to find, let's get f of -3 by itself by subtracting the integral from both sides of the equation. So now we have this equation. In the setup of the problem, we were told that f of 0 is equal to 3. So let's substitute 3 for f of 0 in this equation. All we need to find now is the value of the integral from -3 to 0. The integral of a function is the area between the function and the x-axis. If the area is above the x-axis, the area is positive. If it's below the x-axis, the area is negative. The area of the yellow triangle, 1/2 base times height, that's 1/2 1 times 1. The area is positive 1/2. How about the negative area? 1/2 base times height would be 1/2 2 times 2. So that's half of 4, which is 2. So let's put a -2 because it is a negative area. Distributing the negative sign, we have 3 minus 1/2 plus 2. So 3 plus 2 is 5, minus 1/2 is 4.5. So this is the value of f of -3. Now let's find the value of f of 4. To find the value of f of 4, let's set up an equation involving a starting value, an ending value, and the change in between. If you take the starting value f of 0 and add the change in f from 0 to 4, you should get the value of f at 4. Just remember that the change in f from 0 to 4 is the same as the integral of f prime from 0 to 4. So we have this equation. We already know that f of 0 is 3. So we just need to find the value of this integral. Remember that the integral of f prime is going to be the area between the function and the x-axis. And keep in mind that because this area is below the x-axis, it will have a negative value. We can calculate the blue area that we want using the area of the outer rectangle and the area of this semicircle on the inside. Specifically, the blue area will equal the rectangle minus the semicircle. However, remember that we want the blue area to be negative. So let's do semicircle minus rectangle. That's the smaller area minus the larger area. That way, the blue area will be negative like we want. You know that the area of a circle is pi r squared. So the area of a semicircle will be half that. In this case, the radius is 2. So this becomes 1/2 pi 2 squared. So this is pi times 4, or 4 pi, and then half of 4 pi is 2 pi. So the area of the semicircle is 2 pi. How about the rectangle? Of course, the area of a rectangle is base times height. So the base is 4 and the height is 2. So that's going to be 2 times 4, which is 8. So this blue area, which represents the integral of f prime from 0 to 4, is 2 pi minus 8. So we have 3 plus 2 pi minus 8 is equal to f of 4. And f of 4 is what we're trying to find. So let's just simplify this. We have 3 minus 8, so that gives us 2 pi minus 5. And that's the answer. Just to summarize, f of 4 is equal to 2 pi minus 5, and f of negative 3 equals 4.5.